In this video, I'm going to explain how to draw Lewis diagrams for atoms and molecules. The molecules that I'm going to explain are the following molecules written here. First, we start with atoms. When we want to show Lewis diagram for atoms, we need to show the electrons in the outermost shell of atom using dots. Let's go through a couple of examples. We know the number of electrons in the outermost shell of each atom is equal to the group number. It means element of group 1, they have only one electron in their last shell. So we start with lithium. Lithium, 3, and we know it's in group 1, so it's only have one electron in its outermost shell. So we write Li, just one dot. That shows the outermost shell electron. For element of group 2 that has 2 electrons in their outermost shell, so for example, beryllium, we use 2 dot, 1, 2. And let's go to other side of the periodic table, for example, carbon group 14 with 4 electrons, so it means 1, 2, 3, 4. And nitrogen group 15, 5, 1, 2, 3, 4. When you put 4 electrons around, after that you can start pairing that. So the 5th electron is like this. So we start pairing that. And then oxygen in group 16, 6 electron, 1, 2, 3, 4. And then we start pairing 5, 6. Okay, let's go through molecules. I start with molecule of H2O. When you want to write Lewis diagram for molecule, there are some steps that you need to follow. The first step is to calculate the number of electrons in outermost shell of all atoms involved in the molecule. So we see here we have hydrogen. Hydrogen only has 1 electron in outermost shell, so total electron in valence shell. So I say electrons in valence shell equal. So we have 2 hydrogen, each hydrogen only 1 electron times 1. Oxygen group 16, 6 electron plus 6. So we have all together 8 electrons. Then we need to see which atom is our central atom. Usually our central atom is atom that is less electronegative. But in this case, oxygen, we have less oxygen, and also hydrogen only can have 1 bond. So oxygen is our central atom. I put oxygen, that is our central atom, and then I put the other 2 elements around that. So I put with 1 single bond, 1 single bond, 1 hydrogen, 1 single bond, 1 hydrogen. After that, we need to start filling the outermost shell of outer atoms. This one is central, there are outer atoms, but for hydrogen, we know hydrogen only can have 2 electrons. So as we can see, hydrogen is outermost shell of hydrogen is full of electron here because it has 2 electrons, that is bonding electron. And this one also is full of electron because we have 2 electrons as bonding electron. So, but we need to right now fill the outermost shell of oxygen. So we see 2 electrons here that are shared electron between this oxygen and hydrogen, 2 electrons here, 4, but from our 8 electron here, still we have 2 more, 2 pairs. Okay. I put 2 pairs here. Let's see. So I use 2 electrons, 2 electron, 4, 6, 8 electrons all together, and I had 8 electrons. So just I used the number of electrons that I had. Hydrogen, the outermost shell of hydrogen, both hydrogen are full of electrons, and oxygen has 8 electrons outermost shell. So this molecule is, the Lewis diagram is correct. Let's go to next molecule, NF3. Again, the first step is to find electrons, the total electron in valence shell. So we have nitrogen in group 15, so it has 5 electrons in valence shell, plus we have fluorine in group 17, it has 7 electrons in valence shell, so it's 3 times 7, so all together become 21 and 5, 26 electrons. Okay, right now we need to make decision which one is central atom, N or F. We know N electronegativity of F is more than N, so N is our central atom. I put our central atom here, and then I put the other atom that we have 3F around the central atom with a single bond. So I put F, F, F. Next step is to fill the outermost shell of outer atom. So I start 2 electrons here, so still it needs 6 more electrons. So I put 2, 4, 6, 2, 4, 6, 2, 4, 6. As you can see, all fluorine have 8 electrons in their outermost shell, 2, 4, 6, and these 2 bonding electrons, so all together 8. The same thing for all fluorine. So let's see how many electrons we used so far. So 8, 8, 8, 24. Still we have 2 more electrons to use. Let's see if our nitrogen has the outermost shell full of electrons. 2 electrons, 4 electrons, 6 electrons. Nitrogen needs 2 more electrons, and we have 2 leftover electrons. So we put these 2 electrons. We put these 2 electrons here. So we put 2 electrons for nitrogen. 1 and 2. So this is the Lewis diagram for NF3. Let's go through 2 more examples. Again, we have SO2. S group 16 has 6 electrons in outermost shell, plus oxygen, again group 16, 6 electrons in outermost shell, and we have 2 oxygen, 2 times 6, so all together 18. Okay. Next step is deciding which atom is central atom. Between sulfur and oxygen, oxygen is more electronegative. It means sulfur is our central atom. So I put sulfur. And then I put 2 other atoms around sulfur using just single bond. So I put O and O. Okay. After that, we need to complete the outermost shell of outer elements. So I say, okay, 2, 4, 6, 2, 4, 6. Let's see how many electrons we have used so far. 8 electrons here, 8 electrons here. All together, we use 16 electrons. Still, we have 2 more electrons. Okay, just I write a 2 here, not forgetting that. And then I start counting the number of electrons of sulfur. 2, 4. Okay, I have 2 left over. I put it here. But still, sulfur has 6 electrons in outermost shell. How I can fix this problem? I say, okay, sulfur has 6 electrons and wants to have 8 electrons in outermost shell, but I don't have any leftover electrons to use. the solution for this problem is, instead of giving this 2 electron only to oxygen, I cross this one and I put another bond here. What does it mean? It means I give 2 electrons. Instead of giving just to oxygen, I give 2 electrons between S and O. So right now, I just check if all atoms have their outermost shell full of electrons. 2, 4, 6, 8. Oxygen has 8 electrons. This oxygen 2, 4, 6, 8. 8 electrons. And sulfur 2, 4, 6, and 8. So all of them have 8 electrons. And it doesn't matter if you choose this oxygen to have double bond with sulfur or this oxygen. They are the same. So let's go through one more example here, NO3 minus. Okay, again, we start counting the number of electrons in valence shell. Nitrogen group 15, 5 electron plus oxygen group 16, and we have 3 oxygen times 6. And because we have a negative charge, for negative charge, we add 1. And if we have positive charge, we deduct 1. For example, if we have 1 positive charge. If we have 3 positive charge, we deduct 3. If you have 2 negative charge, you add 2. And all together, 18, 19, 24. Next step, choosing our central atom, that between nitrogen and oxygen. Again, we know oxygen is more electronegative, so I put nitrogen as central atom. Then the next step is putting other atoms around the central atom using just a single bond. So I put O, O, and O. Next step is to filling the outermost shell of outer atoms. So I start filling oxygen. So it has 2 here. It needs 6 more. 2 here, 6 more, and 6 more. Okay. Let's see how many electrons we have used and how many left over we have. 8, 8, 8. We use 24 electrons. So it means we don't have any leftover. And also, if we check nitrogen, we see nitrogen have 2 electrons, 4, 6. It doesn't have 8 electrons. Still, it's not, the outermost shell of nitrogen is not full of electrons. So in this case, how we can fix this problem? Again, instead of giving only these 2 electrons only to 1 oxygen, I can cross these 2, and then I put 2 electrons between nitrogen and oxygen. And then, right now, let's see, nitrogen has 8 electrons, this oxygen 8 electrons, 8 electrons, 8 electrons. And it doesn't matter which oxygen you choose to have double bond. And then whole molecule is negatively charged because it's NO3 minus. But how I can find out that is one negative? Let's see. Nitrogen is group 15. But here it has between these 2 shared electrons. If we say 1 is for nitrogen, 1 is for oxygen. So it has 1 electron here, 2 electron, 3, 4. Instead of having 5 electrons, it has 4. So we can say it has 4 mole charge of 1 positive. For oxygen, we say 2 because it's just lone electron. It's just for oxygen. Just I count 2 for oxygen. 2, 4. This shared 1, 1 this one, 1 this one, all together 6. So 4 mole charge for this oxygen is 0 because it's group 16 and it uses 6 electrons. For this oxygen, 2, 4, 6, and one of this one, 7. So 4 mole charge for this oxygen is -1. This oxygen, again, lone, it has 3 pairs of lone electrons, so 6, and one pair of shared electron that we count just one of the shared electron for oxygen. So all together 7 electrons. Again, this one has formal charge of -1. Okay, right now if we look at this one negative charge, formal charge, 2 negative formal charge, and 1 positive charge, the net charge is -1. And it explains that NO3 minus. So because of that, we put 1 negative for whole ions here. And let's go through 2 more examples. Oxygen. Oxygen is group 16. The valence electrons are 2 times 6, 12. So because there are just 2 atoms, I attach them using a single bond, and then I start just filling their outermost shell of electrons. 2, 4, 6, and this 2, 8, 2, 4, 6, 8. Right now, both of them have their 8 electrons. But how many electrons are used? 6 here, 12, and 2, 14. I don't have 14 electrons. We have only 12 electrons. So how we can fix this problem? Instead of giving 2 electrons to this one and 2 electrons to this one, just we put 2 electrons as shared electrons. So let's see right now how many electrons we use and if the outermost shell is full of electrons. So 2, 4, 6, 8. This one is full of electrons. 2, 4, 6, 8. This one also is full of electrons. And how many electrons altogether we use? 2, 4, 6, 8, 10, 12. So we see between 2 oxygen, we have double bond. Right now, let's go through one more example. N, group 15, and we have 2. It means 2 times 5, 10. Again, because we have only 2 atoms, just I use single bond to attach them. And then just I fill the outermost shell. And as you can see, I use 6 and 6. Again, I use 14 electrons, but I only have 10 electrons. To fix this problem, again, something that we can do, instead of for filling the outermost shell electron, instead of giving 2 electrons to this nitrogen and 2 electrons to this nitrogen, I cross this and just I give 2 electrons that they share between each other. Still, they have 8 electrons in their outermost shell. But instead of having lone electrons like this, they have shared electrons. But let's count again. So I have 2, 4, 6, 8, 10, 12. Still, we use 12 electrons. So still it's not correct. We have 12 electrons. We use 12 electrons, but we have only 10 electrons. So we have to cross this 2 and this 2 and giving another shared electron in between. So I rewrite this one. So it's like NN triple bond. If we count the number of electrons in outermost shell of nitrogen, 2, 4, 6, 8. 2, 4, 6, 8. How many electrons we use? 2, 4, and 3 pairs of shared. That is 6. 6 and 4, 10. We have 10 electrons and we use 10 electrons. I hope you found this video useful and thank you for watching.